I want you to think of this problem as only x over x minus 3. All this says is we're going to take this function and we're going to lift it up. It's a vertical shift up 3. So this is the function I'm looking at right now. Let's first talk about a horizontal asymptote. That is always y equals some value. When the degree in the numerator is equivalent to the degree in the denominator, look off to the sideboard. How do we figure out what is the horizontal asymptote? Anybody want to share with me? We take the leading coefficients and we make a ratio. We make a fraction by dividing the leading coefficient on top divided by the bottom. So it's really easy to say, well, I believe that the horizontal asymptote for this would be 1. That's true, but look, we have this vertical shift up 1, so now I need to add 1. Here we have a horizontal asymptote of 2, so this is my horizontal asymptote. Now how do we figure out the vertical asymptote? The vertical asymptote is we're going to take the denominator and we're going to set it equal to 0. I'm adding 3 to the opposite side, and I get x equal 3. Simple enough. Now we were asked to do this without a calculator. So the next thing we're going to do is let's figure out what is the y-intercept. Whenever we figure out the y-intercept, we know x should be 0. So I'm going to put a 0 here for x, and I'm going to come up and just do mental math. 0 divided by 0 minus 3 is negative 3. 0 divided by negative 3 is just 0, and 0 plus 1 is 1. So I'm going to go to 0, 1, and make a dot. Okay, the next thing we want to do is find the x-intercept. So the x-intercept, 0 should be in the y. I'm going to take this function here, I'm going to put 0 in for the y. So down here, I'm going to do 0 equals x over x minus 3 plus 1. I'm going to start by moving 1 to the opposite side. Now we have different ways of doing this, but here's one way. Can you see down below what I'm doing? Okay, down below, I'm going to take and I'm going to distribute. So negative 1 times x minus 3 equals 1 times x. So distribute, I get negative x plus 3 equals x. I'm going to add x to the opposite side. Can you still see on the board? Yes. And I have 2x divided by 2 divided by 2. X equals 3 halves. So we could come up here and write 3 halves, or I also know that's 1.5, however you want to think of it. So 1.5 is like right here. Those are appropriate points, and I did need to name those. Now my next thing is I need to show should there be a point over here or a point over here to determine what it looks like. So I'm going to choose one value to the right of the vertical asymptote. Remember, a function will never cross or touch a vertical asymptote. It can intersect with a horizontal asymptote an unlimited number of times. 1, 2, 3, 4. Okay, I need to do 4. Let's figure out, when I do 4, what is the output? So I'm coming back over here, and I'm just going to do scratch work. I'm substituting 4. 4 minus 3 is 1. 4 divided by 1 is 4. 4 plus 1 is 5. I'm going to go over 4 and up 5. 1, 2, 3, 4, 5. That's enough work for me to show that you know exactly where it should be. So continue to work in the classroom while I go through this. So I'm going to first look at my horizontal asymptote. So 2 divided by 1, because the degrees are the same, 2 divided by 1, the ratio would give me 2. But remember, we have this vertical shift down 3. So y equals negative 1. Go to Ms. Diaz real quick before you come back, before you sit by John. She had something to ask you about something. So y equals negative 1 is going to be my horizontal asymptote. Now my vertical asymptote is x minus 1 equals 0. Move to the other side, so x equals 1. All right, so now how do we figure out what my y-intercept is? I'm going to put 0 in for x and do the math. 2 times 0 is 0. 0 divided by negative 1 is still 0. 0 minus 3 is negative 3. And let's do the x-intercept. For the x-intercept, y is 0. So I'm putting this equal to 0, and this may be the harder point for most of you. And I'm going to add 3 to the opposite side. And then I'm going to choose just to cross multiply. So 3 times x minus 1 equals 2x. So 3x minus 3, make sure to distribute to both items, equals 2x. And we can do this however you want. I'm going to move this over to have 1x minus 3 equals 0. I add 3 to the opposite side, and I get an answer of x equals 3. You know what? I have 1 point here and I have 1 point here, and I've already identified what the intercepts are. That's it. That's justified enough for you to be able to graph this. Let's take a look right now. If you could shut your markers, look back up here. Let's see how far you got and how much that you actually produced on your own was correct. This was the function you were asked to graph without using a graphing device. So we see no x on top. That's the same as x to the 0. So I'm going to start by identifying the horizontal asymptote. We do want to write it as an equation, y equals. When the degree on top is less than the degree on the bottom, we would say that we have a horizontal asymptote on 0. But look, we have this vertical shift down 3. So actually, sorry, that's an ugly 3. Actually, our horizontal asymptote occurs at -3. Now, for our vertical asymptote, I'm going to take the denominator, I'm going to set it equal to 0. And yes, we'd normally have 2 answers, but we know that there's no such thing as plus or minus 0. There's only 0. So I have a horizontal asymptote of x equals 0. So it's harder to see in here, so I'm going to use my highlighter. These will be my asymptotes. Our function can never cross the vertical asymptote or touch it. It can cross a horizontal asymptote an unlimited number of times. Okay, the next thing is I want to remind you, if you've forgotten, that 1 over x squared produces this basic shape. I often think of it, it looks kind of like a volcano, so just keep that in mind. So the next thing I'm going to do is I'm going to take this original function up here, and I'm going to decide what is the y-intercept. So I'm going to set 0 equal for x, and uh-oh, we have problems here. Can we have 0 on the bottom? Can we do that? It's not. Do you guys agree it's not possible? It's not possible. So what does that mean? Does that mean I'm going to have a y-intercept? I'm going to have no y-intercept. It does not exist, no y-intercept, because I can't take 2 divided by 0. That's impossible. So there is no y-intercept. Let's try the x-intercept. So if x-intercepts, I'm just going to do the opposite. 0 goes in for y. So I come up to this original function, and I put 0 in for y over 2x squared minus 3. I'm going to add 3 to the other side. And this is what I have. I'm going to choose to cross multiply here. I have 3x squared equals 2 divided by 3 divided by 3. I have x squared equals 2/3. So this is what it's looking like. This makes it a little difficult, but if they want exact answers and they don't want us to round, let's take a look at what this looks like. Okay, so for exact answers, I'm going to have plus or minus the square root of 2 over the square root of 3, but we know we can't leave a radical on the bottom. So times radical 3 times radical 3, I have room down here, x equals plus or minus the square root of 6 over the square root of 9, and we know the square root of 9 is 3. So if we had to give exact answers on a test, positive radical 6 over 3 and negative radical 6 over 3 would be my answers. I have no idea what that is. So I'm going to come back up here, and let's just see what would that be. Square root of 6, get an answer divided by 3. So we have about a 0.8. So if here's 1, we have a 0.8. And again, it's going to be just the opposite. So we have the square root, negative square root of 6. And then if I divide it again by 3, I have that exact negative answer. So this is what it looks like. We never actually have a y-intercept, and it comes down this far. So when I look at this function, I'm thinking of it as x to the 0. When I come up with a horizontal asymptote, I have this ratio. Excuse me. Look at me making a mistake before I started. I have a degree on top that's smaller than the degree on the bottom, so the horizontal asymptote is going to be 0. But I have this vertical shift, so I actually have an equation of a horizontal asymptote of y equals 2. Now, the denominator has a vertical asymptote of x minus 4 equals 0. I add 4 to the other side, and I get x equals 4. So this is what I have. Now, let's figure out what is the y-intercept. So I'm going to substitute 0 in for x. Okay, what does this original equation look like before I made it so messy? It looked like this. When I substitute in 0, I get 3 over negative 4, so negative 3/4 plus 2. I need to find a good common denominator. Let's go times 2 and times 2. Negative 3 over 4 plus 4 over 2 would be negative 1 over, did I just do wrong? I meant to be over 4. Goodness sakes, I'm trying to rush here and making mistakes. Let's go like this. There we go. That still is equivalent to our 2. So this is going to give me a positive 5 over 4. Positive 5 over 4. Now, positive 5 over 4, I know, is 1.25. Okay, so I'm going to go 0 and 1.25, right about there. Now, let's find what the x-intercept is. So for the x-intercept, I need y to equal 0. So I'm going to come up here, I'm going to make y equal to 0. And I'm going to start by subtracting 2 to the opposite side. I'm going to cross multiply. I'm going to distribute to get negative 2 plus 8 equals 3. I'm I'm going to subtract 3 to the opposite side. Well, 3 minus 8 is negative 5. Divide by negative 2, and I have two negatives make a positive, and I have 5 over 2. Well, 5 over 2 is the same as 2.5. So 5 over 2 is the same as 2.5. Here's 2.5, and that's enough for me to see what it looks like down here. I'm choosing one number over here, 1, 2, 3, 4. I'm going to choose 5, and I want to see when I plug in 5, what is the output? So I'm going to come back up here, plug in 5. 3 over 5 minus 4. Well, 3 over 5 minus 4 is 1, and 3 plus 2 is 5. Let's go over 5 and up 5. There's 1, 2, 3, 4, 5.